Hey everybody, welcome to week 1, 2, 3, I believe. And I thought, since we're all getting a little bit crazy, we would start off today's lesson with maybe some funny math jokes. So here's a couple. Why do plants hate math? It gives them square roots. And we'll do one more. Why is the obtuse triangle always so frustrated? Because it is never right. Hey, if you like the math jokes, feel free to put a cute little math joke or a funny dad joke or something in the beginning of your video. Also, makes us all a little more lighthearted and have a little bit more fun. So anyway, I hope to hear at least some of you guys put a little funny joke there in the beginning of your videos so I can laugh too. But back to business. So we are going to be doing volume of prisms and cylinders today, okay? And the formula and everything in this chapter is going to be formula based. Is the volume of a prism and the volume of a cylinder is going to be the same formula, okay? And that is V, or volume, equals capital B times H. Capital B is the area of the base, okay? And the bases of prisms or cylinders or whatever it happens to be, the bases are parallel to each other. Think of like the top and the bottom, or the left and the right, something like that. And the height is the perpendicular distance between the bases. So if you notice, like on the problem here on the left, or on the prism on the left, the height is just straight down, but on the right, it's a slanted prism, so the height is actually straight down, not going to be your slant height over here, okay? The hardest part about the volume of these things is the bases can be any shape. So you have to know the formula for area of squares, triangles, trapezoids, pentagons, hexagons, all of those things that you've done before. And once you have that area of that base, you just take it times the height. So what we're going to do on the next slide, just write down a couple of the formulas that we should know, because these are formulas that are going to come up in the in the volume problems. And we just did area of a circle last week, I believe it was. And the area of a circle, if you remember, has to do with the radius from the center out, and it is pi r squared. These are going to be good formulas to have written down here somewhere to go back to if you need them. Area of a triangle. Okay, so I'm just going to draw a random triangle here. The area is 1/2 the base times the height. And in this case, our base and our height, they're perpendicular to each other. So our base goes across the bottom, and our height is perpendicular to the base. So the base and the height are perpendicular to each other. The area of a square, rectangle, parallelogram, any of those is just area equals base times height. Notice I'm using a lowercase b for base in this case. So a lot of times we think of a square, we think of squares as being like the side squared. Like squares and rectangles quite often we think of as length times width. Well, the length and the width of a square and a rectangle are perpendicular to each other, so those are the base and the height. It's the same thing. A parallelogram, remember, looks kind of like that, where you'd have a base and then that height will actually be perpendicular to that base. Okay, then we have a trapezoid. This is one kids always forget. Okay, so the area of a trapezoid is 1/2 the height times the sum of the bases. So if I just draw myself a little trapezoid over here, remember a trapezoid has one pair of parallel sides. Okay, so the parallel sides are our bases, and then the perpendicular distance between them is the height. Okay, and then what we just did last week also was the area of a regular polygon, and the area of a regular polygon is 1/2 a times capital P. So I hope you're thinking in your mind that you remember what lowercase a and capital P are. There's a lot of lowercase and capital letters in this unit, so you have to kind of keep track of what they actually are all meaning. And remember, A is the apothem and P is the perimeter. So a quick reminder here, let's just draw maybe a hexagon. It's not going to be a perfectly regular hexagon, but remember, if we had a central angle like that, each central angle is going to be 360 divided by 6 because it's a hexagon. The apothem goes from the center straight down perpendicular to the side. So just a reminder that that is the apothem. And a couple things is the apothem bisects that central angle, and it also splits the side of the polygon in half. Okay, so again, these are good to have written down somewhere in case you can't remember them. You can refer back. Okay, so we just have a few on this next slide that we're going to do. And it's a prism. The first thing we want to identify is what are the bases, okay? And anytime you have a three-dimensional shape flattened out onto a flat piece of paper, it's kind of hard to visualize. But if we look, we've got here, that's the bottom, that's the top, okay? Those two are our bases, okay? And the distance between those bases, let's see here, from one of the bases to the other is our height. Okay, so our formula for the volume of a prism is the area of the base, capital B, times the height. So the way I always explain how to do these is I break the formula apart, okay, and I say capital B is the base. Well, what shape is the base? Well, we've highlighted that the base is a triangle. Okay, and then I know the formula for the area of a triangle. That's 1/2. Now we're looking at the base and the height of just that triangle. So we would have the base and the height of the triangle. Okay, so the area of the base, which is a triangle, is 1/2. Okay, so let's look at our picture. It's going to be easier to look at the top where everything is labeled. B times H. So we would have 1/2 of 6 times 8. So the area of our base, if you put that into your calculator, 6 times 8 is 48, divided by 2 is 24. Okay, now we need to actually go back and plug that in. So we'd have our volume equals capital B, we said was 24, times our height, which is the distance between the bases, which in this case is 7. If we take 24 times 7, the volume of that triangular prism is 168 centimeters cubed. Okay, so that's what it looks like with a triangular base. We're just going to look at the same formula with a lot of different bases. Okay, so the next one, a lot of you probably think about this one as just being like a prism that you would think of looks like a cereal box or something. And quite often you think of it as length times width times height, which is very true, but we're going to think about it so that when we start getting not rectangular bottoms or tops for bases, that we know how to do those. So again, we're going to have the area of the base times the height. Again, the base is here and here. Okay, well, if we think logically, that's a rectangular base, or base, oops. Or, gosh, I don't need to write with a pen. There we go. Our base is a rectangle. Okay, and the area of a rectangle is base times height, or length times width, which would be 10 times 4 in this case, or 40. And then we can just take, and we'd have our volume is our area of our base, which is 40, times our height, which is the distance between our bases, which is 40 times 12. And 40 times 12 is 480, what are we in? Inches cubed. Okay, oh, and it looks like on the first one that I did, that should have been centimeters, not meters. But it is important to note that we should label everything since this is volume. It's three-dimensional, so we're going to have labels that are cubed. So whatever it is, it's like inches cubed, meters cubed, centimeters cubed. All right, this one, if you notice, our bases that are parallel to each other, the bottom and the top, are not circles because it looks like you basically took a cylinder and sliced it right down the middle. So our volume, let's go ahead and write our formula, is capital B times H. Okay, our base is a half or a semicircle. So if we think about how to find the area of that base, remember area of a whole circle is pi r squared, but we only want half the circle, so we divide it by 2. So we would have our radius, so the whole distance across here is 4, which means our radius equals 2. So we would have pi times 2 squared over 2. So the area of our base is going to be 6.28. And then we're just going to take, to find our volume, we take the area of our base, which is 6.28, and multiply it by our height, the distance between the two bases, and we get 15. And again, this is a lot of calculator work once we get to here. 6.28 times 15 is 94.2 centimeters cubed. Okay, they do get a little bit more difficult, some of them. Some of these might seem pretty simple. Okay, so now we have a couple of more prisms. A looks like it's going to be a prism that has a parallelogram for bases, and B looks like the bases are going to be trapezoids. So we're just trying all kinds of different bases to figure out how to find the volume of these. So our volume is going to be area of the base times the height. Okay, our base is a parallelogram. Okay, because our base is going to be this front, the way I see it, this front, and then it's not all marked, but if we had the back here, that would be the other base of it. So we would have our base is going to be base times height, little like the base of the parallelogram times the height of the parallelogram. So we have to be careful what numbers we want to use. So if you look, these are the parallel sides here, okay, of our parallelogram. So our base of our parallelogram is 9, and the height, or the distance between, is 4. They put this 5 here just to confuse you a little bit. You don't actually need to use it for anything. So you would get that the area of the base is 36, and then the distance between the bases, so be careful, again, we don't even need that 5, because the distance between the bases, in this case, from front to back, is 14. So our volume is going to be 36, which is the area of our base, times 14, which is the distance between our bases, or the height, which gives us 36 times 14 is 504 centimeters cubed. Now I'm just going to do a quick sketch on this here, up here. Oops, there we go. Because maybe I was going to try to erase. Here we go. Okay, so maybe you saw the bases as this side here, and then what would be this side over here that you can't really tell. Okay, in that case, the area of the base would be 14 times 4. So I'm just going to write that up here. The area of the base would have been 14 times 4. And the distance between those two bases would have been 9. So either way that you could have seen it, you could have done 14 times 4 times 9, or that would be 36 times 14, which is the same thing that we got. So depending on how you see it, your work might look slightly different depending on, sometimes their bases can be different, especially with parallelograms and rectangles and squares. Okay. So on this one, we have to use the trapezoids as the base of the prism. So again, I always start with the same thing. You guys might think, my gosh, that seems repetitious. Oh, so it's the area of the base times the height. Okay, my base is a trapezoid, which means my formula, if you need to go back on that front sheet, or on the front slide, it's 1/2 the height times the sum of the bases. B1 plus B2. Oops, B2. There we go. Okay, so the area of the base. Okay, so here we have, if we look at our picture here, here is the bottom. Here's the top. We have to be a little bit careful here with the numbers that we're using. Okay, so as I see my picture, okay, one of my bases, okay, of my trapezoid is going to be 6. The other base is 14. Okay, now that's because this side length here and this side length here are the same, and they're both 14. And this side length here and this side length here are both 6. So our capital, or our, excuse me, our little side, or our bases, B1 and B2, are going to be 6 and 14. The height of our trapezoid is the distance between our bases, which is this value right here, which is 3. So if we put in our formula, we have 1/2. The distance between the bases is our height, which we said was 3. The sum of our bases is 14 plus 6. And when we put all of that into our calculator, we get 20 times 3 divided by 2, which is 30 centimeters. And then we can go ahead and say the volume of the whole thing is the area of the base, which is 30, times the distance between those bases. So the distance between the trapezoids is right here, which is 5. And our volume is going to be 150, what are we in? Centimeters cubed. Okay, now we just have some cylinders. I have a regular cylinder and a cylinder that is slanted. So we'd have the volume is going to be the area of the base times the height. Same thing as always. So our base is a circle. So we're going to use pi r squared. That's the area of a circle. So our base is going to be, the radius is 9. So we're going to have 81 times pi. Okay, which is 254.47. So the area of our base is roughly 254. Our volume, we just take the area of the base and multiply it by the height, which is 6. And we get about, let's see here, 1,526.82 feet cubed. Okay, again, I'm not going to spend a ton of time. This one is very, very similar. Our volume is going to be the area of the base times the height. Our base is a circle, pi r squared. So our radius is 4. So we're going to have 16 pi. 16 pi is 50.27. And then our volume is going to be the area of our base times our height, which is the distance between the two bases. As you can see, that's 7. And you multiply them together and you get 351.89 centimeters cubed. Okay, I have one more because we've done circle, parallelogram, triangle, trapezoid for bases, all of those things. Now we're going to incorporate what we did last week into this week. So we have a hexagonal prism, is what you would call, or hexagonal, however you want to pronounce it. But you do the exact same thing. You're going to have to do a little bit more work to find the area of the base. Okay, so we have the volume as the area of the base times the height. Same. Our base is a hexagon. And the area of a regular hexagon is 1/2 the apothem times the perimeter. Okay, the perimeter is going to be easy to find because we can see that each side length of this hexagon is 2. So we know that the perimeter is going to be 2 times 6, which is 12. Now we just have to think back to last week on how we figured out what the apothem was, because that's the other thing that we're going to have to find. So if you remember, if we have the hexagon, I'm going to zoom in here a little bit. Let me erase what I put around the outside. So remember, we think we're going to be in the center. We draw that central angle, like so. Those are our radii, okay, from the center to a vertex. Then we go ahead and drop in the apothem that's perpendicular, and that's our A value. Okay, I'm just going to zoom in a little bit more here. And we know that if we have a hexagon, that's going to be 360 degrees divided by 6, which is 60 degrees. So we know each central angle is 60 degrees, but then we also know that when we drop that apothem in, that's going to be 30 degrees right there. Okay, then we also know that apothem breaks that side in half. So we know that this piece right here is 1. So now we just need to figure out what is A. Well, we're going to have to use a little bit of trig. Okay, so let's find a little spot over here. Okay, so I would have 30 degrees, 1, I should have, oops. Okay, 1 is opposite of the 30 degrees. The apothem is adjacent. Okay, so actually I'm going to go right over here to the left of it. Opposite and adjacent says we use tangent. So the tangent of 30 is opposite, which is 1, over the adjacent, which is the apothem. When we do our cross multiplying, we get that A equals 1 divided by the tangent of 30. And if we go ahead and put that into our calculator, we should get that the apothem is approximately 1.73. Okay, so let's come back over here. Oh, I've got a big black mark going through the middle there. Okay, so that I know the area of my hexagon here is going to be 1/2. We said the apothem was 1.73 times the perimeter, and since each side length is 2, it's a hexagon. 2 times 6 is 12. If we multiply those together, 1/2 times 1.73 times 12 is going to be 10.38. Now we have our capital B, which is the area of our base. So the volume is going to be 10.38 times the height. Remember, the height is the distance between our two hexagons. So if we have, here's the hexagon in the front, and it's not really drawn in there, but there's the hexagon in the back. This distance right here is the distance between them, and it is 5. So the 5 is going to be our height. And our volume is going to be, when we multiply those together, we get 51.9 feet cubed. Okay, so we had all kinds of different shapes of bases. So you always have to think, what is the base? How do I find its area? And then take that area and multiply it by the height of the prism, which is the distance between those bases. So for today, again, this is going to be similar to what we did last week, because anytime you have all of this rounding and all of these steps, big ideas, it's very, very easy to be like 100th off and it will count it wrong. So there's no big ideas assignment. There's just a worksheet. It's 2 or 3 pages. There's like 10 or 12 questions, I think. I can't remember. And there's an answer key that is posted in Schoology, so you can work them out and check it with the key. Last week I did all the work. I showed all the steps on how to do them. This week I did not. I just put the key with the answers. I want you to work through the problems and make sure that you can get the answers correct. If you are not getting correct answers with the work that you are doing, please join my Zoom sessions on Tuesday and Thursday at 10 a.m. and we can go through some of those questions. And then once you have finished that worksheet, you can check it with the key, you can ask questions, and then there's a demonstration of mastery, which basically is this, where you have to find the volume of prisms with different shapes for bases. So have a great day, and I hope to hear some of your funny jokes in the video that you send me. Thanks, bye.